A point charge A of 4 microcoulomb and another point charge B of charge minus 1 microcoulomb are placed in air at a distance of 1 meter apart. Then the distance of the point on the line joining the charges and from the charge B, where the resultant electric field is 0. So the point where the net electric field is 0 is called null point. So we have to locate the null point from the smaller magnitude of the charge. So this is the smaller magnitude of the charge. And so this is higher magnitude of charge. For unlike charges, the null point will be outside the charges on the same line joining the charges. Outside the charges, but very nearer to the smaller magnitude of the charge. So here the total separation between the two charges is 1 meter. So this is the data given here. So here I have charge A 4 microcoulomb. Here I have charge B minus 1 microcoulomb. And the null point will be outside the charges on the same line, but it will be outside the charges. So I'll give you the shortcut formula here. The shortcut formula here is, say the total separation is D. The shortcut formula here is X is equal to the separation between the two charges divided by root over Q2 by Q1 minus 1. So Q1 is that charge from which we measure the distance of the null point. So from which charge we are measuring the distance of the null point? 1 microcoulomb. So that will become Q1 and the other charge will become Q2. Don't substitute the negative sign of the charge here. So X is equal to D. So D is the total separation, that is 1 meter divided by Q2 is 4 divided by 1. Q1 is 1. So minus 1. So we will be getting here 1 divided by 2 minus 1. So which is equal to 1 meter. So the distance of the null point from the charge B is 1 meter. That is the answer. So option A is correct.